Alright, let's dive into something mind-blowing. Imagine staring at the sun, not just a blurry orange disk, but its surface in unprecedented detail. I'm talking about the highest resolution image ever captured of our star, and it's revealing things we've never seen before. What makes this really interesting is that it's not just a pretty picture, it's a game-changer for how we understand the sun's behavior. Personally, I think this is one of those moments where technology pushes us past the limits of what we thought was possible. Here's the deal. The image was taken by the Daniel K. Inouye Solar Telescope in Hawaii, and it shows tiny, whirlpool-like plasma patterns on the sun's surface. These aren't just random swirls, they're linked to something called Kelvin-Helmholtz instabilities. Now, if you're like me, you're probably thinking, what does that even mean? In simple terms, it's a fluid dynamics effect where two fluids moving at different speeds create ripples or vortices. But here's the kicker, this is happening on the sun. We're talking about plasma, not water, and the scales are insane. Some of these vortices are just 20 kilometers wide, yet they're visible from millions of kilometers away. It's like spotting a coin from 180 kilometers, absolutely wild. What many people don't realize is that these tiny processes could explain some of the sun's biggest mysteries. For instance, why is the sun's outer atmosphere so ridiculously hot? And how does magnetic energy move around its surface? Researchers are suggesting that these vortices might be key. From my perspective, this is where science gets exciting, when small, almost imperceptible details turn out to be the missing pieces of a much larger puzzle. It's like discovering that a single thread holds together an entire tapestry. One thing that immediately stands out is how this connects to the sun's magnetic activity. The image focuses on a region near a sunspot, which is already a magnetically intense area. These vortices are forming at the edges of granules, cell-like structures on the sun's surface that are constantly churning. If you take a step back and think about it, this is a perfect example of how chaos and order coexist in nature. The sun's surface is both violently dynamic and intricately structured, and these vortices are right at that intersection. A detail I find fascinating is how this discovery challenges our assumptions. We've known about Kelvin-Helmholtz instabilities for a while, they happen in oceans, clouds, even in fusion experiments. But proving they exist on the sun? That's new. It raises a deeper question, how universal are these processes? If they're happening on our star, could they be shaping other celestial bodies too? Personally, I think this opens up a whole new avenue for astrophysics research. What this really suggests is that we're only scratching the surface, literally and figuratively. Sami Solanki, a leading researcher on this, pointed out that these minute processes are what define the sun's nature. It's humbling, right? Our star, which has been studied for centuries, still has secrets hidden in plain sight. In my opinion, this is a reminder that even the most familiar things can surprise us if we look closely enough. So, here's my closing thought. This image isn't just a scientific achievement, it's a call to curiosity. It makes me wonder what else we're missing, not just about the sun, but about the universe as a whole. What do you think? Are these tiny vortices just a cool detail, or do they hint at something bigger? Let me know in the comments, I'd love to hear your take.